So we're going to continue on lesson 2, part 2. We started looking at closures. We're going to do a couple of other examples. So I just want to explain a couple of the other benefits of closures, and I think they'll be illustrated a bit more by our other examples. So there's a couple of other reasons why having this wrapper around our function is useful. One reason is in JavaScript, just like in other languages, every time we create a function, the processor has to allocate memory to that function, which means if we want to call a function multiple times, like let's say sending an email out to a list of 1,000 users, if every time we call the function, basically it creates a spot in memory, the function runs, and then that memory gets released. So if we have to send 1,000 emails, that's 1,000 times the function takes a spot in memory, runs, gets released, has to get created all over again. So there's a performance cost to doing this. With closures, by wrapping that function, it basically allows us to create that spot in memory once and execute it multiple times without that object having to get destroyed and recreated every time. So it's got that performance. So by wrapping one in another, we can create it once and hold it. So we're going to get a performance benefit. The other thing that's valuable is it has to do with variable use. So by wrapping, by declaring our variable here and making it accessible inside, again, variables, every time you create a variable, you're you're asking the server for memory allocation. Create a space, create an object called message, and store this value in it. But if we want to reuse this value multiple times, or use it in multiple functions, the closure lets us do this without creating the variable globally. I mean, one simple example, if we want to use message here and here, is yeah, we could just declare message up at the top outside, and that would work. But this comes at a big, big performance cost. In general, it's best practice to avoid global variables in JavaScript whenever we can. Why? What are some of the drawbacks of declaring your variables globally so that they can be reused in multiple places?
They're held in memory.
Right? Because if we declare it at the top of our page, the entire life cycle of the page, that variable's held in memory. Yep, that's one reason, right? Right, if we're using, so could you expand on that? I'll just repeat that for the video. So they can be modified. If they're declared globally and used in many places, they might get changed. Could you think of an example? Like, what do you think? You're absolutely right. Yeah, there's a good chance that one function may change the variable in a way we don't want to if it's that one value that's shared everywhere. Blair, you're going to say something else? Okay. Those are absolutely among the best reasons. We also have issues with JavaScript has a lot of globally named objects, like the window object, for example. So our variables might conflict with built-in global JavaScript objects. We may get naming issues. It also makes, if we want to do things like unit testing, really difficult. Because if a variable gets passed along and modified by a whole series of functions, well, how do you test in isolation part of that code if that variable is being used? So closures allow us kind of the best of both worlds. We can have a variable accessible within multiple functions, but we can basically set it so that this variable only lives within the scope of the parent. Like, what would happen if we do this here? I'm sure we can just do it up here. If we were to run the file this way, what result, so I'm just modifying my example 1 for a minute. What result will we get when we run this file now? So we want to log out our message variable. What result would you expect? Undefined, okay. Right. So message doesn't get created, it doesn't exist till here. What if I move this down here? If we run it again, will message print a hello world, or are we going to get another undefined? So it prints it out first time. So our message variable, it's accessible in the child function, but it's still basically what's called a block level variable. It only lives inside of this closure. So we can access message anywhere inside of the closure, but not outside. It's not global. So we can control the scope of where that variable is accessed. And in a couple other examples, I'll take that out. We're going to do, we can see this a bit more clearly. So I'll create a new JavaScript file. I'll call this one, I may as well use, I'll call this one open function. So we're going to write a function, we won't use a closure, and then we'll rewrite the same code with the closure and we'll see how it behaves differently. And Vasu, you had a few interesting questions at the break, we'll address some of those. Again, it doesn't really matter what you call the file, I'm just trying to give it a fairly descriptive name. Or you can call this one no closure if you want. Create a function to be called multiple times without a closure. So this example is straight from that tutorial that I've linked to on Blackboard. So we'll create a numeric variable, a counter, we'll initialize it to 0. And then every time this function gets called, we'll add 1 to the counter and log it out. So we'll just use counter plus plus. We'll log it out. Then we want to execute this function more than once. So let's say we want to execute it twice. That's what she did in the tutorial. We can follow along. How would we get this function to run 2 times? There's a couple of easy ways we could do it. Either would be correct. What would be the simplest? Okay. So we call open function once, and call it again. So we haven't used the closure here. This is just plain JavaScript. We have a function that we're going to execute 2 times. So let's go to our console. I'll call open function. Just before I do, what do you expect the result is going to be? Right? You think it's going to print 1 twice? Okay, any other predictions? Agree with Brian? You think it'll do something else? So when we run it, I get 1, and I get 1 again. We can call this function 1,000 times, 1,000,000 times, 1,000,000,000 times. It's going to print 1 every single time. Why is it going to print 1 every time it runs? Right, because every time we call open function this way, the function gets created in memory, our counter variable gets created and initialized, our code runs, adds 1 to it, and prints it, And then that function and any variables that live inside it get released from memory. So if we want this code to run multiple times, this isn't very efficient. And it means our value can't persist without a global variable, right? Maybe this value is maybe this function's doing something like calculating the total in a shopping cart, where we want it to loop through and we want that to be a running total. We don't want to reinitialize the value every single time. We want to keep the current value and then add the next item in the shopping cart on top of it. So this is not efficient from a memory perspective. It also doesn't allow us to keep our variable. It gets destroyed and whatever value we were working with is gone, and we may want to keep it. So let's rewrite this using a closure. So we'll make one more file. We'll make a new JavaScript file. I'll call this one closed function. So this time we'll call it closed function. And again, we'll create and initialize the exact same variable. So we need a second variable for this. We called our first one counter. I'll call my second one increment. They mean similar things. So we're assigning our variable to an anonymous function. This function has no name. So here's our. So in here, we're going to increment and log. Add one and display value. And then our parent function, our closure, so we're returning the variable that's assigned to this child function. So this way, our function only gets created once, our counter variable only gets created once, and the value will persist. It doesn't get destroyed each time this executes. So it's much more memory efficient. So we're creating a new variable and we assign it equal to our closure. So this creates our closure in memory and it creates our counter variable. It's an initial value of 0. So create closure and counter in memory once. And then we can execute it twice. So now we just call increment I guess I should just move my comment around. So first, we create the closure. It instantiates and initializes our counter value to 0. And then we execute the function twice. But instead of creating it in memory once, running it and destroying it, and then repeating, we're creating it, and then we can execute it. So if I run this version, you can see in the terminal, I now get 1 the first time, and the second time we call it, our counter variable persists. So we haven't wiped out, destroyed that value the second time. So it allows us to treat this not as a global variable, but a persistent variable for whenever we want to work with this function. So doing something in a loop where we're keeping track of how many times is this loop executing, that's what we're doing here. That would be a really common example in a real world application. We need to do something multiple times, but we need to keep track of and maybe display to the user how many times this is happening. Maybe this is a search result page. So our closure function might be run the database query that goes and fetches all of the notebooks in Amazon database. And then we have a child function that will run in a loop that says display each book, each product. But at the top of the search results, we need to show 87,300 results. So we could initialize a counter here. And as we display each book, we can increment that counter. And we don't have to recreate that each time. So this sort of structure where we are assigning a variable equal to the result of a function, we're going to see this over and over again with our node syntax. And if we come back to what we did before we even wrote these, that's what's happening here. Create a variable and assign that variable equal to the result of a function. I realize this is new and it's different from anything we've done in any of the languages we've worked with. It will take a little while of us coding this until we start to feel more comfortable with it. That's okay. Here's the full code. Sorry? You want to see the open function for a minute? Okay, I'll leave this one up for another minute, and then I'll put up the open function. Vasu, I'm just going to come back to you because do you have more questions, or did we clarify the things we were talking about? Okay. That's allowed and encouraged. So please have a look through that article on Medium. It may ask you to log in. I think you can log in like to Medium with Google, GitHub, almost anything. So you don't have to create an account there. So that full article may not be public. If you're an anonymous user, I'm not sure. It may ask you to log in. Sure. That's a good question. You know what? I would think this should work, Ryan. Let's try it. Let's try it. I followed the example syntax she used in the tutorial. This is a good question, so I'll just hit the up arrow and try to run it again. Rashad, I will put open back in a minute. I didn't forget you. Okay. Actually, I like their syntax better. That's simpler.
The first one you can return more than one variable. The first example.
Ah.
You can add more and more.
Okay.
Yeah.
So if we use, and those would probably be comma separated, I think. I haven't tried it. Is that how you did? Did you with comma? So we could return multiple variables comma separated.
Like in case like some cases you declare the library and you
Right.
call a lot of functions or variable inside of library.
Right.
We use it so
Right. And we'll use that syntax when we're writing our Angular component and Angular services. Yes, we'll use that to import multiple libraries on or multiple components from a library in one line of code. So we will use that syntax. Okay. I think for now, yeah, Ryan, I think for now this syntax is a little simpler. So I'll leave it like this rather than introduce something else new. Either way. Okay, I will put back open function. So you can see in this, the difference between these files, it's not just a syntax difference. We get different output in this way. And this is okay, but we have to know that we want to be destroying and starting all over again every time. We don't want, in this case, our variables to persist. But many times we do want those variables to persist because we need to work with them through a few different functions. Actually, what I will do, I'll upload these 4 files we've done so far. I'll put them up on Git right now. So if you need anything else from them, you can get them. Okay, so if you need anything else, those files are on Git now. We'll probably create one more file today that we'll wind up pushing up there, or 1 or 2 more. So we will come back and we'll be using closures every week. So we're going to get more and more comfortable with them. I'll try to highlight some of the closure features again, just to touch on them as we're writing code over the next few weeks. Okay. So the next thing I wanted to have a look at is NPM. So this is kind of the second half of the slides from last week. So it's in the week 1 folder. I'm not going to read this stuff to you. I think the slides are fairly concise, but I just want to touch on some of the important features. So NPM stands for Node Package Manager. So it's a really widely used modular system because Node is so basic. We set up a site, we don't really get anything. We have to do everything manually, even so far create the web server. So NPM is a modular system. So most Node in general is open source. So developers create libraries, they create utilities, and they can publish them to NPM. So typically on NPM, we'll have a look in a minute. We can look for packages. So let's say we want to do something like we did with ASP.NET. We want to enable Google authentication. Or rather than write all that code, we can go to NPM, we can search for a package, and all of the packages on NPM, all the source code is typically on GitHub. So when we install a package, it pulls a version of the source code from GitHub and adds it to our project. And typically this is done through the command line. So if we're looking for something on NPM, the main page is here, it's npmjs.com. So let's say we want something like, let's say, I don't know, Google Auth. So there's a bunch of different packages. And NPM will give us some info. So this one's pretty current, last updated 8 days ago. This is Google, this is from Google, and it gives us the code. Here's how you would install it in your project. NPM install, the name of the library, and if there's multiple words, they're always separated by hyphens. That's the NPM naming convention. They don't use camel case or underscores. And typically, it'll give you on NPM, typically we'll get documentation right here. This is how you install it. Here's some sample code. This is how you would use it. And then over here, so there's two ways to install it. This version is old. They've shortened the command so you can now use I instead of the word install. So it's always npm I or npm install and then the name of the package. It adds it to your project. It'll show you how popular it is. Pretty popular, 2.7 million downloads in a week, the last week, when it was posted. And there's typically a link to the Git repository. So you can actually go and inspect the code. So when we do npm I, basically npm downloads a copy, a latest copy of the repository from GitHub into your project, is how this works. So, and they've got all the docs here on GitHub. Here's the README file that we learned how to create last semester. So there's tons of stuff on NPM. Also notice it tells you how many dependencies. So if we install this library, NPM is also going to install these libraries. So one package often depends on many others. And we saw this with Visual Studio with NuGet, right? We went to install a package and we'd often get a pop-up saying, this package wants you to install all these other packages because this one isn't going to run without the other. So NPM's same thing. We can also see which packages on NPM require you to install Google Auth. So if you want to install the YouTube video rename package, it's going to automatically give you this Google Auth library because this is a dependency of that. We'll come back to this in a second. So typically, there's two ways we can install packages. We might install a package for a particular application only. So, you know, I've got a whole bunch of Node applications, but I need a particular piece of functionality for this one. So I would just run the command npm I, name of the package. It will install it in my project only. If I try to use it in a different project, I don't have access to it. That's kind of how we did things with Visual Studio and NuGet. However, there's another option here. NPM has a global install option. So this is for things like development tools. So there's some handy development NPM packages that make our life easier when we're programming. We don't need them at runtime. We need them when we're working. So if we install them globally, we can use that package on any project on our machine. We don't have to install it over and over again. If we say, hey, I like this utility, I don't have to install it every time I make a new project, add it. It can just be global, and then I can use it with any project. So that's kind of cool. So something like Express, which is part, you know, which, as Linda knows, is the E in mean stack, right? Express we're going to install when we're going to want to install globally. We're going to use it in all our projects. So we'll do that as a global install. So when we install, if we just add this -G, that's saying install this not in the local project, install it in my global node cache, package cache on my machine. So we'll use both of these today. We'll try a local package install just for today's folder, and we'll also try a global NPM package because there's a really useful utility we're going to want to use. Dustin. Yes and no. Express itself, yes. There's also a tool which we're going to use called the Express Generator. It's a scaffolding tool, kind of like Visual Studio's project templates, although not as big, much more lightweight. So the Express Generator is a utility that creates a working Express site. And that's what we're going to use to build most of our apps. So the Express, yes, we'll want that in each project, but the Express Generator will install globally, and we'll use that utility to scaffold Express sites. So yes, you're thinking about it in the right way. Good question. So here's what happens when you install them locally. If we install a package locally for a specific project, Node is going to look for a subfolder in our project called node_modules. If that folder doesn't exist, NPM will create it. And then inside of node modules, it will install the dependency as well as any sub packages that needs. So for example, I'll show you from last semester. So here was my simple lesson 3. We just had 2 simple files. So here's the node modules folder. And these were the NPM packages we installed. Now, we didn't install all of these directly. We only installed 1 or 2 of them, and the others were dependencies of the things we picked. I think Connect was the only package we actually installed. The other 11 packages, when you install Connect, you get the other 11, because Connect requires all of those. You can remove packages if you don't need them. You can update them because the versions do change. And then Node has a file. Once we install our first NPM package, Node has a JSON file that keeps track of all the packages. What are the dependencies of the project and what versions? So this is useful if we take on a new project or we get added into an existing project. We may want to look at this file to know what packages it's using. The other nice thing about this package.json is the packages can get big. There can be a lot of dependencies. When we push to Git, the node modules get ignored. So the node modules won't get uploaded. So what happens is if you upload your project to me and I want to run it, when I download, all I get is your node code. I don't get, the potentially millions of packages you've installed. But the package.json, it will list which packages your project needs and what versions. So I can just, with a simple command, package.json will say, okay, Blair's project had 20 packages. I have his Git repository. It doesn't include the packages, has a list of what they are. So I can do a package restore. Again, like in Visual Studio, the same thing. When you downloaded my code off GitHub, Visual Studio would restore the packages so you could run the code. So NPM works the same way. So and there's like a wizard, simple wizard at the command line for creating this package.json. It's in the screenshot, it's a little hard to see. It'll just create a JSON file and all our projects are gonna have it. Okay. So this is the rest of this stuff's just kind of here as a reference. There's one gotcha. We need to spend a few minutes talking about this before we use NPM. We'll probably take a break before we do. This is 10 years old now, but Node's been around for a while because Ryan Dahl created, I think it was 2008. We looked at the talk. The story is NPM and the 17 lines of code that broke the internet. It's actually a really interesting story. I've linked to it here. I won't read the whole thing, but we should talk about, because A, it's an interesting story, and B, it has some implications for us as a developer. So here's what happened. You have to be mindful when your application relies on NPM packages, you don't own those packages. You have a copy of them, but the developers still have control over that code. So here's what happened. When was this? there was a developer who'd created an NPM package by the name of Kik, K-I-K. And this package was super popular. It was really tiny. There were 17 lines of JavaScript in it. And I think it was used so that developers, if they wanted text to be write justified, it had a little library that you could write justify text. So it was quite popular, but in particular, it was a dependency of this other JavaScript interpreter called Babel that maybe you've heard of or used before. Babel is massively popular. In fact, if we look how many uses, the core, we're going to see millions of dependencies. Yeah. Downloaded 11 million times a week. And Babel used this little Kik utility as one of its dependencies, okay? Just so that people could write justify some text. Pretty simple thing. The problem was there is another company, web development company called Kik Interactive. And they had some kind of mobile app. Well, they found out that there was an NPM package called Kik, and that used their trademark. They'd paid and registered the name Kik, K-I-K. So they told the developer of the NPM package, you need to change your name. This is our trademark. You're infringing on it. And the guy said, look, this is an open source package. It's on NPM. It's used in millions of sites because any site that uses Babel has Kik as a subdependency. And he basically told them where to go. I think they asked him for $25,000. Oh yeah, here's what he said. You can buy it for me for $30,000. This is just something I did for fun. You can read about their fight. Anyway, they threatened to sue him. So he said, fine, I'll take my package off NPM. So this broke every site that used Babel because Babel now couldn't use Kik. So every site that was using Babel, 11.5 million downloads a week, couldn't use it. No more updates. So it's open source. So you should read some of the details. So yeah, here's what it was. So people got these errors, right? When they tried to then, it was a left justification. They tried to get it, people got these errors. Oh, this was, yeah, one of the modules. It was called LeftPad. Yes, and it was used to write justify text. And Babel used it. So millions of sites went down when this happened. So this is, I mean, NPM is great, but it can happen. It's worth reading the story. And the guy basically said, the original developer said, I'm not putting stuff on NPM anymore. And there's a whole discussion here about NPM. And he was saying, we need to find an alternative to NPM where this kind of stuff can't happen because too many people are now reliant on it. So we can't really build in the node world without NPM. We're kind of restricted to it. But I mean, that's a very big caveat. Doesn't happen often, but it can happen. So I've linked to that article here. Their conversation's actually pretty funny between the two of them. Okay, it's a bit early, but rather than just start into the next thing and break, does anybody have any questions about anything we've done in this hour before we have a pause? About closures, about NPM? Okay, we'll take 10 minutes and then we'll create a simple file without NPM. Then we'll start looking at how NPM works. We'll do a quick review of a few JavaScript basics and I'll give you a lab to take home. It will be due Friday afternoon, end of the week. Okay, we'll take a 10-minute break here.